Please make sure you have your copy of Limiting and Excess Reactants, a lab we're going to do to balance a reaction chemically. So take a look on the back of the first page, the procedures, and what you'll see is a couple of data tables. The one on the bottom shows 7 different groups and how much of each of the 2 reactants you're going to use for your particular group. We're going to combine citric acid and sodium hydroxide, which is a base. Acids and bases in a neutralization reaction release heat, which we'll measure by looking at a temperature change. Our goal is to try different mole ratios, different ratios of the 2 reactants. Each milliliter of these 2 reactants has the same number of moles of reactant. So that's how we'll achieve these ratios. So I'm looking at my bench and I see that I'm at group 6. And so according to the data table here, for group 6, I'm going to use 45 milliliters of citric acid and 15 milliliters of sodium hydroxide. So 45 and 15, I'm going to keep track of that right here. That's how much I'm going to use. And I'm going to prepare 3 trials. And for each of the 3 trials, I'm going to record the starting temperature and the ending temperature of the reaction. So when I look at my materials, I see that there's a label, it's color-coded for my group, and there's a matching graduated cylinder for each of the 2 reactants. The citric acid and the sodium hydroxide are different amounts, so I put the labels so that you can see how much you're going to use. So like for the citric acid one for group 6, it's going to use 45 milliliters, so I put the bottom of the label right at the 45 milliliter mark. So what you'll do is fill up the graduated cylinder to the bottom of the label for the ingredient that you're adding. So for citric acid, I'll put 45 milliliters in here. And the sodium hydroxide, according to my data table, I'm using 15 milliliters. So I put the bottom of the label right at the 15 milliliter mark on the graduated cylinder. So I'll put 15 milliliters of sodium hydroxide in. So make sure that you look at the labels to see that they match, so that you don't cross-contaminate the reactants before you do the experiment. So what I'm going to do is, I'm going to take the ingredient that is more, which for my group is the citric acid, 45 milliliters, and I'm going to put 45 milliliters into each of the 3 bigger cups, because it's the bigger ingredient. And then I'm going to take 15 milliliters and put it into each of the smaller cups, because it's the smaller ingredient for sodium hydroxide. Then, to find the starting temperature of the reaction, I'm going to take the one that's bigger, and I'll put it with the thermometer, and I'll measure the starting temperature on the thermometer and record that for the starting temperature of my first trial, and then I'll add the sodium hydroxide and give it a good swirl, and while it's reacting, I'll watch the thermometer go up, and when it reaches its highest point, I'll record that as my ending temperature. And then when that trial is over, I'll start the next trial. Now the starting temperature for all 3 of these should be the same because it's room temperature. So whatever you got for the starting temperature of the first trial, you can go ahead and record that for the second and third trials. The ending temperature is what we're really after. So make sure that you add the other ingredient, the one that's less, and swirl. And when the temperature stops going up, then record the ending result. And do that for all 3 of the trials, like so, and swirl and measure the ending temperature. Then what you'll need to do is find out what's the average. So take the temperature changes that you got by subtraction. The temperature change, take the ending temperature minus the starting temperature. You should get a positive number because the temperature went up. And to find an average, you add together the results and divide the total by 3. We'll put the average results up on the screen so everyone can see what the class average is. And then we'll find out which ratio gives us the most reaction. The most reaction is achieved when there's the least leftovers, when there's no excess or limiting reactants, when the ratio is the same as for the balanced reaction equation, which will compare to a reaction equation that will balance together. When you're all done, the instructions say that you can throw away the cups. Please don't throw them away. Let's be economical. Just rinse them out in the sink and then put them back on the tray the way that you found them. Thank you.